we have to start with this topic 9.8, two samples, estimating the difference between two means. Okay, in the last class we have discussed finding confidence interval for a population mean, and we tried finding maximum error allowed, and we can find sample size using formula that's been discussed in the last class. And now we are going to find a similar confidence interval for the difference of two means, two population means. When the population variance are known, the formula is given here. It's looking very similar to the formula that we used in the last class. You remember it? What was the confidence interval? X bar minus Z at alpha over 2, which is sigma over root 10. We have seen, isn't it? Less than mu, less than x bar plus the same error, alpha over 2 sigma over root 10. Isn't it? Okay. Compare these two formulas. This is the formula for two means. So when there are comparison of two means, this mu will be replaced by mu1 and minus mu2, isn't it? Therefore, x bar, the one sample mean, will be replaced by the difference of two sample means on both the sides. So from the same formula, we get this Z alpha 2 will be same, Z alpha 2 will be same. Instead of sigma by n, actually sigma by n is sigma square over n square root under square root. So this is actually sigma over root n. When there are two different sigmas, it will be sigma 1 square over n1 plus sigma 2 square 2 square over sigma 2 square over n2. That's it. That's the difference. And under square root, both the sigmas will come with the square and divided by n1 and n2 respectively. That will be coming in the right side. So when you remember the previous formula, you can remember this formula. It's looking very big, but it's very easy to write. Okay. What is going on? If x1 and x1 bar and x2 bar are means of independent random variables, independent random samples of size n1 and n2 from populations with the known variances sigma 1 square and sigma 2 square. So we are assuming this case is the population variance is known. So there are different cases we are going to discuss. So when population variance is known, you will get sigma 1 square, sigma 2 square. So, and 100 times 1 minus alpha percentage confidence interval. Some confidence interval like 95%, 99% confident. How far you are confident that your difference of two means will fall in this interval. The confidence level will be given. From the confidence level, we are supposed to find alpha and then alpha by 2, and then find z value for which the right side area is alpha by 2. Okay, these are the things we should remember while writing this form. Next case, confidence interval for the difference of two means again, but in this case sigma square, sigma 1 and sigma 2 are equal. Two variants are equal but unknown. We are not aware what is exact value of sigma 1 and sigma 2. But given that they are from the same population, maybe both the population have same variance, isn't it? Therefore, if we don't have an idea of what is the population variance, we will always find the sample variance, S square. So here it should have been S square on both sides, isn't it? And if we take commonly S square out of the root, it will be S. We call it here SP, the pooled estimate of the population standard deviation. It is actually we are estimating population standard deviation by using sample standard deviation. See? So it's called pooled estimate of the population standard deviation, SP. Almost all are same. Instead of Z, we are using T table because this is for small samples. For small samples, we can always use T distribution can replace Z distribution. So if you want to find the value of T for alpha by 2, isn't it? We need degrees of freedom. And when there are two different n1 and n2, the degrees of freedom is n1 plus n2 minus 2. So that we can find a T value that leaves alpha, the area alpha by 2 to the right side for the degrees of freedom n1 plus n2 minus 2. The formula pattern is the same. You can check the previous one. Z has been replaced by T. Sigma has been replaced by sigma 1 and sigma 2. Both are equal, so we call it SP square, a pooled estimation of the standard deviation. Right. So either SP square will be given, or we will calculate. If it's not given, it is going to be a bigger problem to find it. Right. Okay. Third one. So here read the statement: if x1, x2 are means of independent random samples of sizes n1 and n2, and the normal population, so they fall in normal distribution with unknown but equal variances. This is the point to be underlined. Unknown but equal variances, and thus confidence level has been given for the mean to fall in this interval. So this interval, for sure, this percentage 99 or 95, 90 or something, will certainly contain this difference between two means. Okay, that's the second case. And third case. So remember, first case we have found two different means with the two different variants known from the population. Second case, two different means but the same variance, but unknown. Unknown, we have to go with it. Sample variance, pooled estimate of sample population standard deviation. Here, third case is the difference between two means. We are going to find the confidence interval the same, x1 minus x2 bar, x1 minus x2 plus here minus, it is plus here. Everything is same, but s1 and s2 are different, so we cannot take commonly outside. We will write inside. Instead of sigma 1 square and sigma 2 square from the first formula, use s1 square and s2 square. That's it. And instead of t table, instead of z table, we use t table. When our S comes, it will be almost small samples. You can easily calculate what small samples variance is easy. So for small samples, most popular distribution is T. So T will be used. And finding the degrees of freedom is going to be a slightly cumbersome task with this formula. And sometimes we will give B value directly, 10 or 15. Isn't it? If not given, you have to use the variance n1, the variance of first sample, variance of second sample, and the sample size. The same variance and the sample size should be mixed up to get this, right? So for the case 3, we expect to give sometimes the time permits, you will be given time to solve and find B, the degrees of freedom. Otherwise, if we want to give problem for a few minutes, we will give the degrees of freedom, right? This formula B is known as Ware's correction. And let's go to the exercise problems. Check in which case B fall. Okay, we are taking problem number 1 from textbook. This 9.35. In our count, it's problem number 1, textbook 9.3. Collect the information from the problem. Do we have two samples? Then the difference between, yes, the question is find 94%. See, most popular confidence intervals are 99%, 95%. Sometimes they will go to 94, 96, 92. But we are equipped to find for any given confidence interval, confidence level, right? It's okay. Let's start. Okay. Temporarily, the question is to find confidence interval for the difference of two means. And before writing the formula, let's collect the information. Sample size 1, n1 is 25. Sample size 2, n2 is 36. Yes, we have two different sample sizes. And do we have different standard deviation? Yes, sigma 1 is given. So this is the case 1. Case 1, what is it? Confidence interval for mu1 minus mu2 when sigma 1 square and they are not equal but known. Isn't it? Known. Case number 1. There's different. Sigma 1 is 5. Sigma 2 is 3. Given here sigma 2. X1 bar, sample mean. X1 bar, you can write X1 bar is 80. X2 bar is 75. Okay, almost we have everything. Now we have to find what is alpha. What is the confidence level? Confidence level CL is confidence level is 94 percentage. It will give significant level alpha. Significant level alpha. Alpha is 4%, which is 0.06 actually 6%. 1 minus alpha. So confidence level will give you 1 minus alpha, which is 0.94. Therefore, alpha is 0.06. Okay. And what is alpha by 2? 0.03. Isn't it? This is what we need. And we want to find the A and the Z or alpha over 2. It means that the area to the right side of Z is alpha over 2. Alpha by 2 0. So what is left side area? Left side area is 0 0.9 0.97, isn't it? 97 because total becomes 1. This is okay. And so left side area. So for this left side area, find Z value from the table. You can find in the left side. If the area is 9.97 on the left side, the nearest value will give you 1.88. From the Z table, I think you might have the table with you right now. If not, verify with the table. We have all the information. What is the formula? What is the formula? Write down the formula. Upper limit and lower limit, isn't it? Lower limit, theta lower cap. x1 bar minus x2 bar, the values of the random variables, minus z alpha over 2, and under square root sigma 1 square over n1 plus sigma 2 square over n2. This will give the lower limit. When you change the sign into plus, it will give you upper limit for the interval. Isn't it? The same terms here and here. Difference is not difference, it is addition, right? That's it. Now can we find this one? Oh, let me solve it here. One part, theta lower capital L. What is x1 bar? 80 minus 75. Use calculator. I think these are very easy to solve. Z value is 1.88. Under square root sigma 1 square. Sigma 1 is 5, sigma 1 square is 25. And the samples n1 is also 25. And sigma 2 square is 9 over 36. And no need to manually do, you are allowed to use calculator. So what is the value of this one? You use calculator and check the value. Is it 2.9? Check. Second is upper limit. That is theta r cap. Theta r, that is u cap. I call it u. Upper limit. Upper limit is u. Same 80 minus 75. Instead of minus, we use plus. The same terms should be repeated again. Under square root 25 over 25 plus 9 over 36. When you add this error with x1 bar minus x2 bar, you will get 7.1. Now we got the interval. So answer is ANS stands for answer. 2.9 less than mu1 minus mu2 less than 7.1. This is your answer. So we are done with this problem, right? 9.36. Next problem. Again, read and identify the case. There are only three cases we have seen. Either two variants are not equal and unknown. They are equal and known. There are three cases. Non-equal and known. There are three cases. We will check. Fine. Two kinds of thread are being compared for strength. 50 pieces of each type. The sample size is given 50 each. Isn't it 50 pieces of each type? So type 1, type 2. We call it sample size N1 50, N2 50. Okay, two different samples. Brand A has average tensile strength. So average of first one, X1 bar 78.3, X2 bar, what is it? 87, average of the brand B, 87.2. Standard deviation for case 1, that is sigma. Is it population standard deviation or sample standard deviation? Two kinds. Brand A has an average tensile strength, not a sample, a standard deviation of the population. Something. Sigma 1 is equal to 5.6, and here sigma 2 is equal to sigma 1 for sample 1, that is from the population. Sigma 2 is 6.3. 6.3 is given here, standard deviation 6.3. Now, again, we have to use the same formula and same method repeats, isn't it? Because two different standard deviations which are known. Okay, therefore the same formula we have to use. Before using the formula, find Z value. What is confidence level? 95%. Confidence level CL is 95%, which will give significant level alpha. Significant level alpha is 5%, which is 0.05, and alpha over 2 is 0.025. Divide 0.05 by 2. For this alpha over 2, we have to find Z value. So right side area is 0.07. What is Z value? Is it alpha over 2, leaving the area alpha by 2 to the right side of the curve. Okay? So what is left side area? Left side area is subtract this one from 1. It's 0.975. Okay, for 0.975, the area falling in the left side of Z value is 0.975. From the table, find Z alpha of Z value, which is 1.96. Verify your table from the Z table, isn't it? Okay, now we go to write the same formula, upper limit, theta, lower limit. Okay, isn't it? X1 bar minus X2 bar minus Z alpha over 2 sigma 1 square over n1 plus sigma 2 square over n2 under square root. When we substitute all the values, x1 bar is 87.2, 87.2 minus 78.3 minus z alpha 2 is 1.96 under square root sigma 1 is 5.6. 5.6 square over n1 is 50 plus 6.3 square over n1 n2 is 50. Solve this one using calculator. Evaluate this one. We will get 6.56, and the upper limit, theta upper limit, is the same, 87.2 minus 78.3, the same formula but with the positive sign, 1.96 here. It will be added, isn't it? Under square root, the same term, 5.6 square over 50 plus 6.3 square over 50. And when you calculate it by using a calculator, the answer is 11.24. So it finds that the answer is ANS, stands for answer. Your interval 6.56 less than mu1 minus mu2 is less than 11.24. So there is a 95% chance that the difference between mu1 and mu2 will fall in this interval. This is called the confidence level of the difference will fall in this interval, right? This is 11.24. That's the end of this problem. Let's go for the third problem. The answer is here. You can check. 9.43 from the textbook. Which method is given here? You see, degrees of freedom has been given. I just don't want to calculate the formula, the bigger formula for B. So we have assumed the degrees of freedom here. If not given, certainly we should evaluate it. We should calculate it. Okay, collect the information from the question. A taxi company is trying to decide whether to purchase brand A or brand B tires for its fleet of taxis. Okay. To estimate the difference in the two brands, an experiment is conducted using 12 of each brand. Now this is brand A. Average is given. S1, the brand, the sample for 12, N1 is 12, N2 is also 12, 12 each. So for this sample, standard deviation is 5,000 kilometers. For this sample, standard deviation is 6,100 kilometers. So we have small samples, and of course we have population sigma 1 and sigma 2 are different but unknown. This is the case, isn't it? There are three cases we have seen, and this is the case where we don't know the population variance, but they are different. Not outside from the rope, isn't it? Under the rope. So what is the formula when they are unknown? I will write the formula for upper limit, lower limit. Q, it's theta actually. As per the textbook, it's theta lower and cap is equal to same first term x1 bar minus x2 bar minus see, it will be t for small samples. T distribution will replace z distribution, right? Okay. T test will replace z. When the sample size is high, t will move to t and z will be same. Now under square root, it will be s1 square divided by n1 plus s2 square divided by n2. We know all the terms. We know x1, x2, s1, s2, n1, n2. The only thing to be found is T alpha 2. First find alpha. Confidence level is 95%, which gives alpha is 0.05. Alpha is called significant level, right? Significance level. And confidence level, significance level. There are two different levels. Fine. So, what is the meaning? Confidence. You are 95% confident that this interval will contain the difference of the mean. So 5% you are not confident. 5% is the chance of error. So probability of type 1 error we will discuss in the next one, right? Alpha over 2 is 0.025, isn't it? 0.025. For again the right side left area will be 0.975, isn't it? 975. So Z alpha 2 value should be based on the left side area. The area we leave right side is 0.25. But we are not finding Z. So we don't want left side area. We are finding T alpha. Okay, I would like to erase this part because we don't want Z alpha. Z alpha 2 will be found if this S1 and S2 are instead of S1 and S2, if we have been given sigma 1 and sigma 2, we will find Z alpha. Now go to T table. T table always gives the area to the right side. So T alpha by 2 stands T 0.05. The value of T will be leaving the area 0.025 to the right side. So obviously from the table alpha value is been given as 0.025. Now in the top you can find 0. What is degrees of freedom? The question comes now. The formula for degrees of freedom is different. You want to write the formula? See the case 3. And it's given here as 21. So for B is 21. B is 21. Alpha, the top row reads 0.025. Go to the T table and you will find the table value of T. We call it critical value T. Yes. In the table we get T value is 2.080. We have seen enough number of times how to find the T value from the table. So I didn't open the T table right now. If you have any doubt on finding T value from the table, you discuss with me during the discussion session, right? 2.080 has been found. Now, quite easy, substitute here. In this formula, when you substitute x1 bar 36300, this is x1 bar, right? Minus 38100 minus what is T alpha 2? 2.080 under square root S1 square 5000 square over N1 is 12. S2 square 6100 square divided by N2 is 12. Calculate all these things, your answer will be negative 6536. This is lower limit. In the similar way, when you add these two terms, calculate separately. Okay, calculate separately. Q, no, it's not Q. It is theta, capital theta, upper limit cap. When you find this one and add them, you will get 2936. Therefore, the final answer is negative 6536 less than mu1 minus mu2 and less than 2936. That's the end of this problem. We are finding the confidence interval in which the difference of two means will fall under the given confidence level. So the answer is here. Next topic. 9.10. Single sample estimating proportion. Proportion is nothing but probability. Estimating the probability, the probability of the population. Large sample confidence intervals for P. Again, we are finding confidence interval for the population proportion. So, what is the meaning here? In the previous case, we have checked where the mu will fall. What is the interval of confidence interval of mu? So, we will find, we have already found theta, lower limit, cap less than mu less than theta 1 theta upper limit, isn't it, for single sample cases. If there are two samples, it will be mu1 minus mu2 in the middle, and the formula is slightly different, isn't it? But here it is not mu, here it is probability. P is the probability, proportion of success, probability of success in a random variable of size n, sample size is n. Probability P, small p is for sample success, probability of success for the sample. If there is no cap, it is for population. Okay? And Q cap is always 1 minus P cap, isn't it? So when there is a cap, it stands that P cap is sample probability, isn't it? And Q cap is also probability of success. Probability of success is P cap, probability of failure is Q cap. If there is no cap, this P, small p, stands for population proportion. So we are going to find the interval for this P. So the formula will involve this one. It's just go to the first formula we have studied, x power minus z alpha 2. You remember, sigma over n less than mu less than the same, x power plus z alpha 2 square root of sigma over n. Isn't it? Similarly, if there is no sigma, what will be the new matter? We have P bar and P cap and Q cap. So multiplication of P cap and Q cap will be occupying the space of sigma. That's it. Okay. Sigma will be replaced by P cap and Q cap in the formula. So you understand now how this one. Z alpha by 2 is Z alpha by 2, same for large samples. For small samples, it will be T. Remember, it will be T alpha 2 if sample size is smaller. The small or large will be decided by the size 30. 30 or more will be considered larger, 30 or less will be considered smaller. Okay. But when the sample size is larger, always T distribution moves to Z distribution. Obviously, it will be Z distribution. Okay, now P bar will be given the following. Instead of X bar, you will get only probability of the sample, success of the sample. So P bar, we will get N, you will get. You have to find Q bar and then use this formula. So this formula for single sample estimation of the probability proportion. Okay, and obviously you know Z alpha by 2 is the Z value leaving an area of alpha by 2 to the right side of the curve. Another one, if P bar is used, so this is your standard error. In this case of mean, we write standard error. We write the error, maximum error allowed. Maximum, not standard error. My standard error is sigma by root n in that case, the previous case. Here, maximum error allowed is sigma alpha, that the quantity that we add or subtract. In the previous case of mu, it was sigma over n. So here the maximum error that we add or subtract is Z alpha over 2 and P cap Q cap over n this time. Therefore, this can be used to find the value of n. What do you get? This error is equal to Z alpha 2 under square root P cap Q cap under square root is n. So square on both sides. This will be e square z square alpha over 2 p cap q cap over n. Now replace n, exchange e and n. So n will be here in the left side. So square alpha by 2 p cap q cap divided by error. So this is the formula for sample size. Sample size. So what will be the minimum sample? So maximum error will give you minimum sample. What will be the minimum sample size so that the error will not exceed this quantity? Okay. This sample size will give you maximum this error. Fine. That's what given on this page. The formula for finding the sample size. Okay, for 90 for some percentage of confidence level. And some information about this formula assume that p bar will not change as we make n larger. This can be a dangerous assumption, especially if p bar is based upon a small sample size. If we don't have an estimate for p bar already, then we can overestimate p by using this formula. That is, p assuming p is 0.5. Give the largest possible estimate for n. If p bar is 0.5, then q bar is also 0.5. Fine. Next chapter is the same proportion, but there are two different proportions now. Can you guess the formula now? We might have found the pattern which is working, isn't it? We have developed a formula for finding the confidence interval of one proportion, isn't it? Now there are two proportions, P1 minus P2. Can you guess the formula? Try for a while, okay? Now, slightly different from our formula for 2 means. Instead of mu1 minus mu2, we have P1 minus P2. Instead of mu1 minus mu2, we have P1 minus x1 bar minus x2 bar, we have the x1 bar minus x2 bar, we have here P1 cap minus P2 cap. Is it alpha 2 is same for large samples? Okay. And instead of sigma 1, we have P1 cap Q1 cap. Sigma 2 square, sigma 1 square, sigma 2 square, we have P1, P2 cap, Q2 cap, isn't it? You understand the pattern now? It's getting the same. So these formulas are looking bigger, but very easy to memorize. By practice, it will be memorized. Now, the problem number 1. Problem number 1. 9.51. In a random sample of 1000 homes in a certain city, it is found that 228 are heated by oil. Find 99% confidence interval for the proportion. Proportion is ratio, isn't it? In other words, we call it probability. How to find the probability? Out of 1000 homes, 2 to 8 are our success, isn't it? So proportion, probability, proportion of the population. Is it our population? No, we get a sample of 1000 homes, isn't it? So this is P cap. N sample size is 1000. A random sample, because we have been given it as a sample. So sample proportion is given 228 out of 1000. This is the probability. You can write 0.228 is your probability. Therefore, what is Q cap? 1 minus P cap, which is 1 minus 0.228, and it is 0.772. We got P cap and Q cap and alpha should be found. What is confidence level, confidence level is 99%. So error level is alpha is 1%. This is 0.01. What is alpha by 2? 0.005. Isn't it? Divide 0.1 by 2. 0.01 divided by 2. We'll get 0.005. Okay. Now, this z value, we want z value. What is the formula for theta lower cap? What is the formula for that one? If it is single sample, the formula says p cap minus z alpha 2 under square root p cap q cap divided by n, isn't it? And we have our p cap, q cap, n. The only thing we need to find is z alpha 2. Z at alpha 2. Isn't it? So alpha 2, the right side area is 0.05. What is the left side area? For z, we should be careful about the left side area. The table gives only the area to the left of z. Area, left side area is 0.995. Isn't it? For this area, if you find z value, z alpha 2 will be, this table, from the table, I find it 2.58. 2.58. Now use the formula here. P bar is 0.228 minus 2.58. This is separate, right? And under square root 0.228 times 0.772 divided by 1000. Use your calculator and the answer is 0.194. Theta upper limit is the same, 0.228, but you use addition between them, and 2.58 and the square root the same, 0.228 square, square 0.772 divided by 1000, and the answer is 0.262. Therefore, the interval, I write the answer here, the top. Answer P lies inside 0.194, lies between 0.194 and 0.262. The chance for P to fall in this interval is 99.99. This 99% chance P will fall in this interval. Clear? So the error possibility is only 1%. That's the end of the first problem, and I think we have one more problem to conclude this topic. What is this? What this question is all about? If we wish to be 98% confident, so confidence level is given. Confidence level is 98%. Alpha is 2%, 0.02. Alpha over 2 is 0.01. Therefore, we want Z alpha. So well, let me check whether we want Z alpha or T alpha. How large is the sample? So question is about the sample size. Find the sample size. How large a sample is needed for the proportion? So we are dealing with the P, isn't it? So where there will be P cap and Q cap, we need to find how for the proportion of defective items is success. Getting a defective item is success. In a process, when it is found that a sample of size 100, n is equal to 100. No, n is the question, but why the sample 100 is given? For 100 sample, 8 are defective. Find the probability. Use this one to find the probability. Okay? We don't want this sample size. We want to know what is the actual sample size. This sample size is given to identify your probability of success. It means probability of success is getting defective, isn't it? 8 out of 100. If you choose 100, you find 8 defective. So probability is 0.08. 0.08. Therefore, probability of failure, no defective, non-defective item is 1 minus P cap is 1 minus 0.08. I need to publish, which is 0.92. So this is P cap, this is Q cap. We have both of these forms. The question of the formula is what is N? N under, when you know P cap and Q cap, the formula is Z alpha over 2 under no square root. Is it alpha over 2? Erase this one. P cap multiplied by Q cap. So they multiply all this and divide by the error. And do we have error here? 98% confident that our sample proportion will be within 0.5 of the two proportion. Proportion plus or minus 0.5 is error. So the error is been given. Error is 0.05. Substitute all the information. So find Z alpha 2 from the table. The right side area 0.01, left side area is left area will be 0.99. So for this area, what is your Z value? Z alpha 2 from the table. We find Z alpha 2, which is 2.33. Check your table. Substitute all those information here. Is that square? There will be square for us. 2.334 square. P cap is 0.08. Q cap is 0.92. 4 divided by 0.05. Evaluate this one. You will find sample size and round it up to the nearest integer. You find n is equal to 160 after rounded up. Round up to the nearest integer. See, 160 is the minimum samples, not 100. If you take 100, you will get 8 pieces defective. It will give you an idea about the probability. So the minimum size of the sample should be 160 to get maximum error 0.8. We should not get an error more than this value, right? So the answer, the sample size should be this one. So whenever you want to get a survey and you want to reduce your error, if you want to reduce error to 0, your sample size should be more. Okay, the more the sample size is, the better the accuracy is. I think this will be the end of the problem, end of the slide. Thank you very much. Thank you very much. We'll stop today's class here.